that I haven't just planned travel in Italy, but I actually have planned, I would say, a couple of eclipse excursions. One was for the 2017 eclipse. I was assistant to the chair of the American Astronomical Society's research venture, where they had 5 sites across the center line. I was a site scout for them and helped define or find good locations. And then I'm going to count this Mazatlan trip as also site scouting, Robert, because I did the site scouting, really. So anyway, he's the tech guy. I'm the site scout. That's how we work together. So this afternoon, we're going to talk about, sorry if I say afternoon, because, you know, it's 3 o'clock in the afternoon here. We're going to start with what is an eclipse. Whoops, sorry, everybody. that slide is anticipating what is an eclipse. Why do they happen? What's the difference between a total and a partial eclipse? How often do they happen? Why do scientists care? Why should you care? And then kind of turning it over to me for planning eclipse travel. So I'm going to turn it over to my partner in crime to explain what a solar eclipse is.
Thank you, Trina. So I imagine many of you get the idea that this is a little bit of a play on the fact that Trina does tours in Italy, and now we're combining it with astronomy. And in a solar eclipse is when there is no sun visible in the sky, even though it might be directly overhead. So one of the things I want to start off with, you know, I'm a physicist by training, and I like to talk about the basics. And so I thought I'd talk a little bit about shadows, because I think it's something that, you know, it seems intuitive and yet is actually kind of complicated at the same time. For instance, things like what is the full moon? And oftentimes I've had conversations with my friends, and you know, I'll make the comment that full moon must rise at sunset, and many people are really surprised about that. And you know, it's a pretty fundamental concept of why the moon is full. It's actually full because it's exactly opposite of the sun in the sky. So I wanted to go over the basics of shadows a little bit, just to ensure that we're all on the same page in the first place. So this, of course, is a picture of the shadow of the Duomo in Florence, taken from the very top of the Duomo. And, you know, when we see a shadow, we think it has sharp edges, but it's actually not a sharp edge. If you were standing on the street below and looking up at the Duomo, there would be one part where you could be like directly in the full shadow and you would not see any of the sun at all. And then you could be stepped outside just a little bit and you would see the entire sun. But in between, there'd be a small area where you could be standing on the street and you could be looking at the sun and all, and part of the sun would be covered by the Duomo and part of it would not be. So let's talk about why that actually happens from a little schematic viewpoint here. So in mathematics and physics, we use the concept of a point source, and you can think of it as just a tiny, tiny source of light. You could, I don't know if you can see it on your screen, but there's a tiny little yellow dot here representing a point source or a very, very small light source. And then imagine you've got some sort of thing here. In this case, you can think of it as the moon. You've got the Earth over here on the right. Well, a point source of light, if you were standing anywhere on the surface of this object here, looking at the direction of the point source, you would not be able to see the point source because it would be hidden behind this thing right here. If you were anywhere up here or down here, you would be able to see the point source. There's a direct line of sight between you and the point source of light, and you would see it. Anywhere in this region here, there is no direct line of sight to the point source. You wouldn't be able to see it. Now, what happens as we move that point source of light further away from the intervening object here? So we move it further away, and now all of a sudden, that area on this object over here, what we call schematically the Earth, any place on the surface of this object in this black region could not see the point source of light. Any place outside of that black region could see the point source of light. And if we go even further, if we move that point source of light to an extreme distance, in mathematics and physics, you would say to an infinite distance, although anything that's 100 million miles away is effectively infinitely distant away. So at that point, those light beams that come from that point source of light are all traveling parallel to your line of sight. And so now the shadow of the object on the Earth would be exactly the same size as the object that's casting the shadow. So anywhere in here, you would not be able to see the point source of light. Anywhere out here, you would see the point source of light. Now let's change the situation a little bit and look at something a little more realistic. Let's look at something like the sun casting a shadow of the moon onto the Earth. Well, if you're standing anywhere in this region right here, you could not see any part of the sun. There's no way you can stand in this region right here and see any part of the sun. Okay, it's like being directly in the shadow of the Duomo. So that's the area of the shadow that we call the umbra. But if you're standing anywhere in this region right here, or this region right here, you would be able to see part of the sun. Part of the sun would be visible anywhere in this region right here. Anywhere in this region right here. So this is what we call the penumbra. Furthermore, if you're standing way out here or out here, you could see the entire sun. The moon would not be obstructing the sun at all. So this is the basics of why this moon casts a shadow, or how the moon casts a shadow on the Earth during a total solar eclipse. Now, of course, that was all schematic. Let's talk about some more realistic images. So a total solar eclipse when it occurs when there's a sun, moon, earth syzygy. Syzygy is a great word for if you're a Scrabble player. Although I don't know if I think there are 4 Ys in a Scrabble game. So I think you can probably play the word syzygy in a Scrabble game if you're lucky and impress everybody. A syzygy is an alignment of 3 objects. In this case, the alignment of the 3 objects is the sun, the moon, and the earth. And the moon has to go between the earth and the sun and be pretty precisely aligned in order to cast its shadow on the surface of the earth. Now, this is a highly unrealistic idea of what the relationship is between the sun, moon, and earth. We can go to this example here, and this is the sun, earth, and moon to scale. Okay, many people don't realize exactly how big the sun is. I hope you can see, you can probably see the earth on your screen here. It's this tiny little dot right there. The moon, you may be able to see it's a tiny little dot right there. I don't even know if I can even see it on my screen right here. But the moon is so tiny you can barely see it. The sun is 100 times the diameter of the earth. The sun's diameter is 100 times the diameter. That means you could fit 1 million Earths into the sun. So when you're looking at the sun at sunset, and don't look at the sun at sunset for too long a period of time, but when it's really close to the horizon, it's maybe shielded by some clouds or haze, you can look at the sun briefly. And you can look at that tiny little sun on the horizon. You can think, well, you could fit 100 Earths across it and 1 million Earths inside of it. And the moon is a quarter of the diameter of the Earth. So this gives you an idea of the scale of these things. Now, to put it to scale, the distances between these objects, I resort to a football analogy, which Trina likes. She's been in the football industry a lot. I used to play football. But let's shrink the sun. The sun is about 1 million miles in diameter. Let's shrink it down to the size of a basketball and put it on the goal line of a football field. And then imagine, where would the Earth and the moon be relative to the sun if the sun was a basketball size object on the goal line? Well, the Earth would be at about the 28-yard line, and it would be about the size of a pea. And the sun's gravity is so strong that even 30 yards away from that basketball-sized object, it managed to hold the Earth in orbit around it. And it takes 1 year, of course, for the Earth to go around the sun. The moon, on the other hand, would be a grape seed-sized object, not a grape seed-sized object next to the pea-sized Earth, and it would only be 3 inches from the Earth. Right, so gives you the scale. 30 yards between the sun and the Earth, 3 inches between the moon and the Earth, and the sun would be a basketball, Earth would be a pea, and the moon would be a grape seed. So that gives you an idea how widely separated these objects are and their actual sizes. So the curious thing is that the sun is 400 times the diameter of the moon. Right, it's 100 times the diameter of the Earth, 400 times the diameter of the moon. But the sun is also 400 times further away from Earth than the moon. And those 2 factors exactly compensate for one another so that they appear to be the same size in our sky. The Earth, the sun, and the moon are really, really close to being the same size. The moon's, and actually the sun's size also, actually vary slightly with time. Very, very slightly they vary. So sometimes the moon is slightly bigger, sometimes it's slightly smaller, and similar with the sun, but with the sun it's much less noticeable. So it turns out that the moon and the sun are about the same size. So if the moon happens to pass in front of the sun and it's perfectly aligned, it can actually cover up the entire sun. So this is now the picture that we have. We have the sun's rays coming from effectively infinity off to the left. The moon blocks out some of the light, and it creates a umbra, this dark pattern right here, the penumbra, the light pattern. And anything outside of the umbra and penumbra would see no eclipse. You would not be able to see any part of the eclipse in this region right here at this particular time. But if you were standing anywhere inside of this dashed circle right here, you would be in the penumbra, and you would be able to see a partial eclipse of the sun. Part of the moon would be covering the sun. And only if you're standing in this tiny little cone right here, at the very tip of this cone, where the moon's shadow just kisses the surface of the Earth, would you be able to see a total eclipse of the sun, where the moon covers the sun entirely. So this now shows an animation of what's going to happen on August 12th, 2026 in about 2 years. This is an eclipse, a total solar eclipse. It's going to be visible over northerly latitudes. It's going to start, so you're going to see this is the penumbra here. You see the umbra showing up right here. It speeds across basically the North Pole. This will continue repeating. It speeds across the North Pole essentially, and cuts across Greenland, just kisses, I think, the western edge of Iceland, and then it passes across Spain and ends at sunset somewhere in the Mediterranean. So, why do scientists care about total solar eclipses? It's an interesting question. In the past, total solar eclipses have been important to scientists for a variety of reasons. In particular, there was a major test of Einstein's general theory of relativity. Einstein's general theory of relativity predicts that gravity bends light beams. And there was a study done during an eclipse expedition to actually measure the amount of bending of starlight due to the sun's gravity. And they found at that time that the amount of bending exactly agreed with Einstein's general theory of relativity and disagreed with Newton's theory of relativity. They also discovered the element helium. We all know helium is the gas that we breathe in, and then we blow up balloons with it so the balloons float, or we can make our voices sound funny. But they discovered helium. Helium was first discovered on the sun during a total solar eclipse. And currently, astronomers go to take images of the sun because this is the best time at which to see the atmosphere of the sun. What you're seeing here is an image of the corona, in other words, the atmosphere of the sun. And all these loops are all due to gases that are being blown off the surface of the sun, and then they're manipulated by the magnetic field of the sun to follow these different lines. It's kind of like iron filings in a magnet that you might have done as a kid. So this is why people astronomers go to see solar eclipses now, is to monitor the atmosphere of the sun, the corona. Well, why should you care about the total solar eclipse? Well, they're awesome. They are mind-boggling. People who I've told in the past to go see one and they don't are always regret it when they hear everybody else describing what they're like. I think there's basically two astronomical phenomena that you should see once in your lifetime. One is the Northern Lights, the Aurora Borealis, and another is a total solar eclipse. Everybody should see one. And if you think you've seen a total solar eclipse but aren't sure, I can guarantee that you've not seen one, because if you saw one, you would remember it. They are that spectacular. They are life-changing events. So what is the difference between a partial and total solar eclipse? Many people, when I've been talking to them in the past and I say, well, you got to go see this total solar eclipse, and they say, well, I'm just 100 miles off the center line where the total solar eclipse is going to occur, so it's going to be 99% where I am. And I say, no, the difference between a total solar eclipse and a partial solar eclipse is really important. And why is that? It's because the sun is 400,000 times brighter than the full moon. Now, the full moon, maybe some of you don't know this, but if you're out in a dark area and there's a full moon out, you can read the newspaper by the light of the full moon. The full moon is bright enough to read a newspaper. The sun is 400,000 times brighter than the full moon. So that means that you need to cover up 99.99975% of the sun for it to be just as bright as the full moon. Okay? So in other words, tiny little sliver on the edge of the sun is still brighter than the full moon. You can still read a newspaper by it. A total solar eclipse covers up the entire sun, and the difference between a partial solar eclipse and a total solar eclipse is effectively infinite. There's no comparison between them. So this here is a movie taken from the GOES 16 satellite that is what's called geostationary orbit around the Earth. And it's taking a picture of that 2017 eclipse that went across most of the United States. So you can see the penumbra crossing the states there, and then the penumbra crosses across. The umbra is a tiny little patch that's the darkest patch in the middle of the shadow there. So I'm just going to repeat that once or twice just to let you see what it looks like. So that's the 2017 eclipse passing over the surface of the Earth. Now, the diameter of totality varies. The diameter of the umbra, the place where you can actually see totality, varies with different eclipses, but it's typically on the order of about hundreds of kilometers, or call it hundreds of miles. The speed of the shadow as it's going across the Earth also varies from about 1,600 kilometers per hour to about 6,500 kilometers per hour. That's about 1,000 miles per hour to about 5,000 miles per hour. So it's moving quite quickly across the surface of the Earth. Many people also ask me, do solar eclipses occur on other planets? Yes, they do, but only on the Earth. is the size of the moon matched so well to the size of the sun that it gives you the best opportunity to see the sun's atmosphere, the sun's corona. On other planets, you can see eclipses, but the moon of the planet would be much bigger in the sky. You're much further from the sun, so you would not have an opportunity to see the sun's corona like you do from Earth. Just to give you an example, this is actual real video taken by one of the NASA landers on Mars. This is one of Mars's moons passing in front of the sun, and you can see that it clearly doesn't cover up the sun. You're not going to get a total solar eclipse on the surface of the moon, but this is, and you can see how irregular the shape of this moon of Mars is. Total solar eclipses also occur on Jupiter. Jupiter does not have a solid surface. This is all the atmosphere of the sun, atmosphere of Jupiter that you're seeing here. But these are three moons. This thing here, this thing here. These are three moons of Jupiter, and these three moons are casting their shadows here. These three shadows right here are being cast by the sunlight. So if you were standing or somehow floating, say, in the atmosphere of Jupiter at any one of these locations, you would see a total eclipse of the sun. But the moon would appear much bigger in the sky than the sun, and you would not be able to see the corona very well. And even so, the sun would be 5 times smaller seen from Jupiter than it is from Earth. And similarly, even on Saturn, Saturn also has total solar eclipses. This is a moon casting a shadow into the atmosphere of Saturn. Once again, if you're floating in Saturn's atmosphere at this point, you would see a total solar eclipse. But from Saturn, the sun appears 10 times smaller than it does from the Earth, and the moon would be much, much bigger, so it would not be nearly as nice a view. So only on the Earth do you get the views that we do now, from the views that are so spectacular. So some people wonder, why don't eclipses happen every month, right? The moon goes around the Earth, so why doesn't the moon go in front of the sun every single month? Well, this is a sort of a screenshot I took using a planetarium package called Stellarium. It is from the city of Leon, Spain, where the total solar eclipse will occur on August 12th, 2026. And what I've done is I've set it to the time of the total solar eclipse, and you can see it says here sun and moon are superimposed on top of one another. The moon is here over the sun. And actually, one of the cool things about this eclipse is it'll happen sort of near sunset. So it'll be a beautiful view towards the horizon. You'll be able to see the planet Jupiter and the planet Mercury in the sky at the same time. And I always get a kick out of the fact that most of the time when I look at Jupiter in the night sky, I'm looking in the opposite direction of the sun. So Jupiter is the opposite direction of us. But in order to see Jupiter during the daytime, during eclipse, we're actually looking across the entire solar system. We're looking to the sun and then beyond the sun to see Jupiter. So Jupiter is much further away than we normally see it. So this is what happens during a total solar eclipse. But the month beforehand, again in Leon, Spain, just 1 month earlier, the sun here is in the daytime sky, and the moon, you can barely see it as a little silhouette right here. But the moon is right here. This is the closest the moon gets to the sun 1 month earlier. So what's happened is that the orbit of the moon around the Earth is not perfectly repetitive. So it doesn't always repeat going over the sun every month. In fact, it only happens about once a year. So a lot of the information that I get about about eclipses, I get from this particular website. I don't expect you to write it down because we're going to send in the chat message the website that I've created a tiny URL for, so it's pretty easy to remember. I created this. It's called tinyurl.com/besteclipsesite, and that will provide you a lot of information about all the upcoming eclipses. And it also has this wonderful interactive eclipse map. I'm going to be showing you some examples just really shortly. But again, I've created a nice website for you called tinyurl.com/interactive-eclipse-map-2026 if you want to explore the path of that eclipse. So how often do total solar eclipses happen? They happen about once per year somewhere on Earth, and about once every 400 years at any location on Earth. Now, there are places on the United States in sort of the Midwest where they got to see 2 eclipses just within the past 10 years. But that's extremely rare. Most places on Earth only get to see an eclipse every 400 years. My birthplace, Niagara Falls, Canada, got to see the 2024 eclipse in April. And of course, I've been excited about it for the last 50 years. Ever since I knew it was going to take place when I turned 61, I thought, man, I can't wait to be back in Niagara Falls to see that eclipse. But of course, I ended up going somewhere else. So this is a map also available on the website I provided showing you the path of total solar eclipses and over the next 20 years, basically. So the yellow lines here are the ones that really to pay attention to. Here's the 2026 one that I've been talking a lot about on August 12th. There's another great one that's happening. It's particularly long in 2027 in August. And then in 2028 in July, late July, there's this other eclipse going over Australia and also New Zealand. So it's kind of interesting. Notice it's always August and July, and there's good reasons for that, which I don't have time to go into. One thing you want to pay attention to when you're planning your eclipse travels is average cloudiness. There are maps available on the website I provide that give average cloudiness around the world during each month. And you can read this. This is the scale over here. So dark blue means that it's highly likely to be clear. Dark red means highly likely to be cloudy. And you can see that in 2026 and also 2027, it's really likely to be clear all over southern Spain and also northern Africa for those two eclipses. So this is a detailed map now from the website I was telling you about for the 2026 eclipse. And you can see, as I said, the red lines here correspond to the path of totality. The blue line corresponds to the center line. You want to be as close to the center line as possible. This little black dot here represents where the eclipse is at its maximum duration, just west of the coast of Iceland. And then it crosses across Spain. And as I said, it ends at sunset in the Mediterranean. But what I want to do is I want to zoom in here a bit. This is zooming in on Spain because I think that's going to be the most likely place to be clear. And you can see again, these lines here represent where it's a total solar eclipse. The blue line is where it's on the center line. You really want to be close to the center line. And this interactive map is great. If you click on the center line, it tells you that this eclipse lasts 1 minute 50 seconds, 1 minute 47 seconds or so. Being a little bit off the center line isn't too bad. In the town of Leon, where we're planning on being, the totality lasts 1 minute 45 seconds. So it's about 1 second different, being just a little bit off the center line. But the further you go from the center line, the shorter the eclipse is going to be. If you're right here, if you lived here and you decided not to go to the center line, here the eclipse lasts just 52 seconds. So you really want to be as close to the center line in a place that has the highest probability of having clear weather. So, an interesting fact, many people don't know this, but the moon is moving further away from Earth by about 3.8 centimeters. That's about 1.5 inches per year. And after about 1.2 billion years, solar eclipses will no longer occur. So in 1.2 billion years, there will be no more total solar eclipses. So you better go see one now.
All right. Thank you so much, Robert, for that tutorial on eclipses. That was fantastic. So now we're going to turn our attention to how to travel to an eclipse. So we're going to talk about choosing a location, what to bring, what to expect, eclipse photography, when to book your trip, and eclipse tours and what to expect. So choosing a location is obviously key. You want to factor in weather and your proximity to the center line for sure, but you also want to choose a place that has maybe a nice background, clear visibility in whichever line you're going to be seeing the sun. In this case, this is where we were in Central Oregon in 2017, which was pretty magical. Where to stay? What's important, and I'm going to stress this several times during this part of the talk, is booking really early. For this visit to the 2017 eclipse, we reserved 2 years in advance. Also for Mazatlan, we reserved 2 years in advance. Those who waited until the last minute paid $100 per night to pitch a tent and stay in porta potties. And that's what can happen if you're in a remote location during the eclipse. It's important to reserve in advance because there are going to be a limited number of nice, comfortable places to stay. Hotels will get booked up really, really early. So important to book very well ahead. And another thing to consider is when to arrive and when to depart. A rule of thumb is you never want to arrive, say, the day before an eclipse, and you don't want to leave the day after because of the amount of traffic. A lot of people wait until the last minute to fly in or drive in, and you can be stuck in some horrible traffic, or you all know what it's like with the airlines these days. So plan to come a couple days before and stay a couple days after. So some things to consider bringing if you go to see an eclipse glasses for sure, a camera, potentially, binoculars, great, or even a small telescope. And let me point out that this red thing down here, it's not what some of you may be thinking it is. It is an actual telescope, which we brought to the 2017 eclipse. And obviously basics like a hat and sunscreen. So Robert, something that you hear about a lot on the news during eclipses is kind of knockoff, fake, forged, whatever, less than ideal eclipse glasses. So if people are going to go to an eclipse, how do they know that the eclipse glasses that they're buying or that they're receiving are good ones?
Yeah, I think it's a little bit like the tainted Halloween candy, that the conspiracy theories about that. And I think it's probably not nearly as bad as the media might make it out to seem. But I think the idea is that just like almost anything, you got to trust your source. So you go online to order glasses, and you make sure that it's a reputable source like Sky and Telescope magazine, or some observatory, or some professional photography company. So I think just a little bit of effort can make a big difference in making sure that you get good quality glasses.
Okay, thank you. Now, I'm going to let Robert take over here because this starts to get a bit technical in terms of photography, and he's done a lot more eclipse and astrophotography, or at least he's known more people who do it than I do. So tell us about photography and cameras.
Yeah, I think unless you're a really, really good photographer, I would be really careful about putting too much time and effort into it. This is my brother-in-law who is very much into photography, astrophotography. So he was really excited about the opportunity to test his skills out on the eclipse. I think that what is more important is to have a good pair of binoculars. This is the binoculars that I have. They're called image stabilized binoculars. So that means, normally when you're holding binoculars, even modest sized ones, you have trouble holding them, especially if something's moving or if it's up in the sky. You have difficulty pointing at the object that you're looking at. But these image stabilized binoculars, they have a little prism inside of them that actually corrects for the fact that you're jiggling around, and it makes the image look rock steady. So you can just point at things and it looks like it's perfectly steady. It looks like a movie. Trina used them to go watch a surfing competition once, and she said it was like watching a surfing movie. You could just follow the surfer across, and it just looked like everything was so smooth and beautiful. And so these are really perfect for looking at the eclipse, wherein you can really just focus on looking at the total solar eclipse rather than being distracted by how much it's jiggling around. Now, you don't need to have image stabilized ones, but I think that they are well worth the price that you would have to pay, the extra cost of getting them compared to a regular pair of binoculars.
Okay, thanks. All right, some things about what to expect. If you go to a solar eclipse in a remote location, expect to run on food. Now, these are mostly photos that I've taken. This was Central Oregon. Expect lines at gas stations. In Oregon, they were concerned that they would run out of fuel for all the people who were coming in for the eclipse. And also expect traffic, terrible traffic. This is an image of from the car that we were in, leaving not the day after, but the next day, even 2 days after. This was the line of traffic leaving Central Oregon to go down to California. Did you have something you wanted to add? Okay, so terrible, terrible traffic. Again, arrive a couple of days early, stay a couple, 2 or 3 days after, especially if you're going to a remote location. Now, I know Reiner went to see the eclipse in Oregon as well, and he had a great strategy for ducking in at the last minute, and he was also the first one out. So there are ways to duck in and out of the center line, but you have to be aware that you could get stuck in traffic, and it'd be a horrible thing to be stuck in traffic heading to the center line and missing the eclipse because you're stuck in traffic. So keep that in mind. There's lots and lots of special activities. There are usually talks or demonstrations. There are concerts. In Mazatlan, there was an orchestra concert happening during the solar eclipse. So prepare for lots of different types of activities. You can see lots of displays. In Mazatlan, they even had a brunch, a special eclipse brunch, and even some special beers here in Oregon. or different foods to celebrate the eclipse. So it really is a huge festival. If you're in a city, this is Mazatlan, expect big crowds. You can see the crowds along the street and along the beach here, which it was a fun place to be, you know, but this is a few hours before the eclipse and it was already pretty crowded. So if you're going to be in a city, make sure that you identify your spot early, go to that place the day before or a couple of days before and look at the angle of the sun at that time. And then figure out, okay, is this place going to be okay? Are there telephone poles or antenna, or are there buildings in the way or something based on the angle of the sun at that time? And with planning, you can find a really nice quiet place. We traveled to Mazatlan with some friends, and we had a beautiful terrace, little patio all to ourselves for the entire eclipse. It was unbelievable that we had that space. Now we're going to turn back to eclipse photography. This is a friend of ours. He's a professional astronomer. Alan, again, you know, he's an astronomer, so he knows something about eclipse photography. So I'm going to turn away to our resident astronomer for photography tips.
So my primary recommendation, especially to people who have never seen an eclipse before, is don't try eclipse photography. Just enjoy it. Enjoy the whole experience. Look up at it with your naked eye. Look at it with binoculars. Experience looking around at the other people who are enjoying it. Just participate in the event and don't get caught up with trying to take photos. Because unless you're really, really good and you really practice, most of your photos are not going to work out well. If you are going to try it, you just demand that you have to have a picture taken by you through your camera at that time. Well, then buy a good solar filter. Practice everything days in advance at the same time. So go out to, like Trina was saying, you go to the exact same location where you're going to be looking at the eclipse at the same time of day, so you know exactly what's going to be in the foreground, what's going to be, what the environment is going to be like, how high the sun is going to be in the sky. Practice setting your camera up, pointing in the sky, and getting it all organized. Because you can't look through your camera in order to see the sun, right? Because the sun's too bright. It'll blow out a lot of your equipment or blow out your eyes. So you don't want to be doing that. So you have to have a lot of practice doing these things. Taking images with iPhones takes a lot of skill. It can be done. I do not recommend it. Focusing is difficult. You have to focus at infinity. And when you're only looking at a blank sky with a sun in it that's not very bright, or it's too bright, then it's really difficult to get your lenses to focus at infinity. And so a lot of your pictures will turn out fuzzy. So search for for online advice before you go. And of course, I can help you I can point you to some websites if you actually would like to follow that path.
Thank you. Okay, so when planning an eclipse trip, Robert has already mentioned the importance of cloud cover and weather. You can see this was the most recent eclipse in April of 2024. And over in Mexico, you can see that the blue area is the one that was the least likely to have cloud cover. And over here, all the way at the bottom in your lower left-hand screen, there's Mazatlan, which is why we chose that versus Robert's hometown up here in Canada.
That's the wrong space.
Sorry.
It's right here. It's right above Buffalo.
I don't know what Canadian geography. Sorry, Ellie. But you never know if the weather's gonna cooperate. This was the forecast, which we were really hanging on for days. It was beautiful sunshine the couple days before, beautiful sunshine the couple days after. And at 11 o'clock, we were really nervous that we were going to have cloud cover. But we ended up having kind of a mixed, high cirrus clouds there. And this is actually during the eclipse, both of these images. The one on the right there is the full sun. Actually, it might be a little bit blocked out with a partial eclipse. The one on the left, no, that's not smog. That's me taking a photo during the eclipse. If we were to blow this up, this is a partial eclipse from my iPhone through the eclipse glasses. So that's what you're seeing there. Now, turning to eclipse tours, there are obviously companies that do tours to eclipses, and it's a great way to not have to deal with the hassle of where am I going to stay. what should I do? How am I, how am I going to handle all of this? And so doing an eclipse tour is a good way to go. And just like any other tour, they're going to organize your hotel and your transportation, which is really helpful because, as you know, hotels book up, and so will transportation as well. They're going to include some meals. They're going to include, in addition to visit to the place or staying in the place where the eclipse will happen, they'll also very likely include some visits to historic or current sites that are important to astronomy. This is the Royal Observatory in Madrid, Spain, because we're talking about the 2026 eclipse. And also, they'll typically have some type of an expert, an astronomer or another scientist, or maybe a professional photographer who will be there to provide some added value and information during the eclipse tour. One of the things that's important to consider with booking a tour is that you need to book these also really far in advance. Our friend Tony, who's on the call right now, I just talked to her this morning, and she booked a tour with a very famous company through Sky and Telescope magazine. I went online this morning to take a look at it. She booked this tour 2 years ago, so 4 years in advance, and this tour is completely sold out and the wait list is closed. And she's also booked for the 2027 eclipse going through Egypt. So booking any kind of travel or any kind of tour, you should really do it as soon as possible. Now, as we've mentioned before, Leon is a place that we think is a great one to be for the 2026 eclipse. You can see Leon here, that almost looks like a sun that Robert's made along the center line, very close through northern Spain. Very low likelihood of cloud cover. So that bit of research Robert and I did, because we are going to be organizing a tour in Spain for the August 2026 eclipse. We have our location, which is going to be Leon. That was where we'll be during the eclipse. So if you're interested in going with us for our first eclipse tour, we're excited about it, and we're excited to be traveling in a guided by style with really good local guides and really good activities surrounding the eclipse. It's important to consider when going to an eclipse, because you could get an odd, random puffy cloud over the sun just at the moment of the eclipse. Plan some activities around it and some sights and some things to do that will make your trip worthwhile, even if you have a rare thunderstorm and it clouds you out for the eclipse. So if you're interested in joining our list to be the first notified of the opening of our tour, please email me at the email address there, and I'll put that into our chat as well. And we'll put you on the priority list and let you know first when we open the tour. But it will be in mid-August. The eclipse again is August the 12th. And we want to thank everybody for joining us for the talk today. Thanks for spending your afternoon or evening with us.